Alright, boys and girls, welcome to video lesson 7-3, our lesson on similar triangles. Okay, do you remember CPCTC back when we proved triangles congruent? We're now proving that triangles are similar, and we have two more sayings you need to know. The first one is CASTC, or CASTIC. CASTIC stands for corresponding angles of similar triangles are congruent. And you know that from what we know from 3-2 about all the angles of similar polygons. All the angles of similar polygons are always congruent. We also know that the sides of similar triangles are proportional. So CSSTP stands for corresponding sides of similar triangles are proportional. Okay, there's three ways to prove triangles similar. There's AA, and we do that by getting any two corresponding angles of triangles congruent. We don't need the third angle because the third angles are already going to be congruent by my favorite theorem, the no-choice theorem. Okay, there's also side-side similarity, and we're going to write that in a proof or just in general as SSS similarity. Okay, when you do that, you need to get proportional sides, so the red sides have got to be in the same ratio as the blue sides and the same ratio as the green sides. All three sides must be in the same ratio. Okay? And SAS similarity, we write that like this, SAS similarity. Okay? In order to get that, you must get one angle, corresponding angles congruent, and then two pairs, the pairs that are between the angle, the included sides, be those in the same ratio. So you got to get the angles, and then the two sides proportional. They don't have to be equal. They need to be proportional. They must be in the same ratio. So, just to remind you, when we were dealing with congruent triangles, we proved triangles congruent through SSS, SAS, ASA, SAA, HL. Notice we don't have donkey. SSA does not work. Once you have triangles congruent, you then use CPCTC after you have proven the triangles congruent. We prove triangles similar with AAA, or you can just do it through AA. You don't need all three angles, but if you have them, that's great. So AA or AAA, SSS similarity, and SAS similarity. Once you have that, you then can use CASTC or CSSTP once you already have triangles similar. All right, let's play a game. This game is called Sim or Not. So the pair of triangles in A, sim or not? Not. Very good. What happened? Not. And the reason is because our ratios are not the same. Yes, we have the equal angles, but 5 to 11 does not equal 3 to 7. And we can prove that by cross multiplying. 7 times 5 is 35. That's a 5. And 11 times 3 is 33. They are not equal, so therefore the ratios are not equal. In this guy right here, we have equal angles. And then 12 to 36 is equal to 13 to 39. Those both can be simplified to 1 to 3. So those ratios are equal, which means these are similar by SAS similarity. Look at these two right here. In C, I want you to figure out if those are proportional, yes or no. And in D, I want you to look at the yellow triangle right here and look at the blue one right here and decide if those two triangles are sim. Okay, in the first one you should have found no. And the reason that is no is because not all the ratios, not all the sides are in the same ratio. So we have 6s to 21. That does equal 8 to 28. But it does not equal 10 to 70. So therefore, all three sides are not proportional. In the second one, we should have found yes, and we can do that by AA. If these two lines are parallel right here, I now know that this angle is congruent to this angle by corresponding angles. I also know that this angle is equal to itself, so we have two angles right there in those two triangles that are sim. I also, just for bonus sake, I also know that this angle is congruent to this angle because those are also corresponding angles. So I could have found that those triangles are similar by AA, or if I wanted to, all three angles, AAA. E and F. You guys try it. Go ahead. Stop the tape. Okay, in this one you should have found no. The sides are not proportional. We have an angle, but then the sides are actually in, oh boy, donkey. I'll write it backwards, SSA. So even if they were proportional, that wouldn't work. And in this case, why are the triangles similar? Well, we have a right angle in both. We can see we have a vertical and a horizontal line for each of those triangles, just by the way the points are. So we have a equal angle, and then this distance right here is 5. This distance right here is 10. This distance right here is 2. This distance right here is 4. So I now know that 5 to 2 is equal to 10 to 4. So these are similar by SAS similarity. Is triangle AEC sim to triangle BDC, and why? Is AE parallel to BD, and why? Let's look at these two triangles. The first one, we'll look at the blue one. That's this one right here, the big one. I'm going to redraw that right here. And then let's look at the black one. I'll draw that one in, or the little guy, we'll draw that one in red. That's right here. Okay, let's label our sides. First of all, we know that this angle is congruent to this angle because it's the same angle. It's angle C. This long side has a length of 7 up here because it's 3 plus 4. And the bottom side has a length of 14. In this triangle, we have 4 and we have 8. So the question now is 4 to 7 equal to 8 to 14? The answer is yes. So therefore, these two triangles are similar by SAS similarity, which means now this angle must be congruent to this angle. We can see them down here because those are corresponding angles of similar triangles, CASTC. Those angles are congruent by CASTC, which means now the lines must be parallel because those two congruent angles make for parallel lines because they're corresponding angles. All right, that's it, folks. Have a great day. We'll see you soon.